Hi, I'm Kurt and welcome to Comp Sci 5. Last time we shunted some yards and we learned about the shunting yard algorithm about turning an infix expression into a postfix expression, which is better for for computer consumption rather. So this was our infix expression and we went to this postfix expression. As promised, I'm going to now teach you how to evaluate postfix expressions using a stack. Stacks and being really handy in computer science. So here's a nice visual of the stack. We can do two operations. We can push a node on top of the stack, or we can pop a node off the top of the stack. And we call the top of the stack the head node. So going to the rules of the postfix stack evaluator, basically very simple. Numbers, we want to push them right onto the stack, but when we get an operator, so if it's like a plus, a minus, a times, or a division, we want to pop. And notice how I have this second here. The first element you pop off of the stack is going to be the second element in this operator. And then you're going to pop again, and then the second element you pop off the stack will be the first element in the operator. So for example, the first element and then the operator, so the second element you pop off, and then an operator, and then the first element you pop off will be the second element. And then when you're all said and done, you push the result. And then when there's no more tokens to process in your queue that's coming in, you just pop the end result and that's your answer. So why don't we go through an example. So this queue should look very familiar to you. It was the result of the last Comp Sci 5 video. So let's just go through. So the first number we see is a 5. And a 5 is a number, so we push it onto the stack. The next number, or the next element in the queue rather, is a number, so again we're going to want to push that onto the stack. Now we get an operator, so we need to pop off the first element, which becomes the second here, and we pop off this one, which becomes the first. 5 times 4 is equal to 20, and we take 20, our answer, and we push it onto the stack. Next we have a 3, that's a number, so we push it onto the stack. We have a 2, so we push it onto the stack. Here we have another operator, so we pop the top element and it becomes the second element in our binary operation. We pop again, this one becomes the first, and now we have 3 times 2, which is equal to 6. So we're going to push that right on top of the stack. Again, we have another operator, so what we're going to do is we're going to pop off the head, becomes the second element. We're going to pop again, it becomes the first. 20 plus 6 is 26. We push the result. We have a 1, which is a number, so we push. Finally, we have a minus, and here's where you can see why the rule is very important. So we pop off this one, the 1, and we don't put it as the first element for the binary operation. Instead, it's the second. And then we pop off this one. So now we have 26 minus 1, which is 25, as opposed to 1 minus 26, which is negative 25. That's a big difference, but we know the right way to do it. So we have 26 minus 1, which is equal to 25. We push it on. We have no more elements left in our queue to process. Therefore, we pop the last element, the head node, which is our answer, 25. Thank you very much. This was Comp Sci 5. We hope you enjoyed it.